Hi, I'm Randall Heyman, a university academic. You're on one of my Corona Help playlists where I do quick turnaround videos to help students and educators during the coronavirus outbreak. If you'd like me to make a video for you, then just email me or comment below any of my videos. And it's not a bad idea if you're happy to let me know what country you're from. I just find it interesting, but also sometimes there are different terms in different countries and I can tailor it a little bit better. Anyway, let's go to what we're here for today. This is for Rosel. And she's having trouble with, where is it? Oh, here it is. She's having trouble with a recurrence relation. AN equals twice AN minus 1 plus A. Actually, let me do the whole thing a little bit clearer. AN equals 2AN minus 1 plus AN minus 2. And we're also told that A1 equals 3 and A2 equals 7. Might just rub out the name here. Okay. First observation is that this is quite similar to the Fibonacci sequence. The Fibonacci sequence is AN equals AN plus AN minus 1 plus AN minus 2. So if you can do this one, you'll be able to do the Fibonacci one, I would imagine. Okay. So, what have we got? We have AN minus 2AN minus 1 minus AN minus 2 equals 0. I should just say I do have a video. In fact, Rosel left this under the video, Recurrence Relations Made Easy, where I go through why some of this works and how to do the problems. But let's just push on with this. So that's that. We now form the characteristic equation. Characteristic equation. And the characteristic equation is lambda squared minus, here we just put 2 lambda minus 1 equals 0. And that giving lambda. Well, this is just a quadratic equation. So I'll just cut to the chase. If Rosel or anyone else is having problems with any of the steps, just let me know and I'll do some more. Okay, so we've solved this characteristic equation, which this characteristic equation here just comes straight from this. It's just a conversion in form, giving that. Okay, so we're up to here. So at this point, we know some of the answer. We know that AN equals, I'm going to call it big A times whatever one of the entries I've got here, 1 plus root 2 to the n minus or plus B1 minus root 2 to the n. And that will be sufficient if the question didn't give you these things here, these initial conditions. Once we have these initial conditions, we can calculate big A and big B. So I'll just leave it there and to find A and B, well, we can say that A1 is equal to 3. We're told it's 3. So that must equal A1 plus root 2. I'm just going to let n equal 1. I'll put a 1 there just so you can, so that it shows 1. And then the next one is 7. So we'll put that here. A2 equals 7. And now we just let n equal 2. So the power goes up to 2. And actually, I was just going to say before people It's probably too late, but if anyone's hanging around but knows how this works, I've got a nice little thing right at the end I'll mention in terms of calculating AN. Okay, so what have we got here? We've got two equations, two unknowns. So I'm just going to cut to the chase on what are the answers, but if anybody can't work it out, then let me know and I'll do another video. So A equals, it's this 1 plus root 2 on 2. So it's semi-coincidental that this A is very close to this term here. A equals that, and B turns out to be 1 minus root 2 on 2. Okay, if you'd want to check, so I suppose the final answer is therefore AN equals, so I take the root, the big A, and I multiply it by what we got from before. And then we multiply, add B times the appropriate power term, which, let me just drop it back. If to see, we're basically putting that A and B into this, and that gives us that. Okay, if you wanted to check, I just for fun, I did a check. A3, well, it should equal 2 times A2 plus A1 equals 2 times 7 plus 3 equals 14. And A3 equal, and also, well, I suppose if we just feed it into this formula, this one up here, we just get, and if you actually work out 1 plus root 2 on 2 times 1 plus root 2 to the power n plus 1 minus root 2 on 2 times 1 minus root 2 on n. If you work all that out, sorry, this 14, sorry, should be 17. And this is 17 as well. So it actually does work. Okay, let me rub this out. Just wanted to make one other comment. Do I want to make one other comment, or maybe more than one? No, I think one comment. You might actually want to write it like this. You can actually, because it turns out that there's that, they're very close, the big A and the power term. You could express it like this. Plus 1 minus root 2 on n plus 1 on 2. Okay, so that's, what have I done there? Oh, well, you can see here. Here we've got a 1 plus root 2, and here we've got 1 plus root 2 to the n. So we can put that all together and get this term here. Okay, so that's what it is. Now, the interesting comment, I think, is that note 1 minus root 2 is approximately negative 0.41. So as n gets larger, 1 minus root 2 to the power of n plus 1 on 2 approaches 0. And very quickly it approaches 0. In other words, once, for example, when I have here, I don't know, n equals 4, well, then I've got approximately 0.41 to the power of 4 on 2. So that's 0.16. I don't know, it's something like, it's very small. It's 0.02 or something, I don't know. You can work it out, it's very small. So what does that mean? Therefore, thus, what I'm saying is AN is approximately equal to 1 plus root 2 on n plus 1 on 2. In other words, what I'm saying is here, this term goes off to 0 quite quickly, and this term is really the main term then, because that one's not, this 1 plus root 2 is actually around 2.4. So this is approximately 2.4 to the n plus 1 on 2. So it's the one that all the action is in the first term. That's what I'm saying. Let's get this fractal off here. And in fact, I think you can show that an equals 1 plus root 2 on 2. So I'll put these 2 marks here. We know it's an integer, an. We know this has to be an integer because it's just a counting problem. Where, so what I'm saying is where, you know, if you've got a number y is the closest integer to y. So here, so what I'm saying is example, what's A100? Whoops, A100. A100 is just the closest integer to 1 plus root 2 to the 101 on 2. So you can get a calculator or computer to very quickly work that out to the nearest integer, and that'll be your answer. Okay, so I hope that's helped Rosel and anyone else that's watching. If you've got any more questions on recurrence relations or anything else, contact me, and if I think I can help, I'll make you a video.